Welcome to this explainer. When we think about sustainability in construction, our minds usually jump straight to the finished product, right? We picture a gleaming skyscraper, an energy-efficient home, or some sprawling new bridge. But today, we're going to look at the shadows cast by those structures. We're diving into the world of waste, the stuff the construction materials industry generates, tracks, and, frankly, struggles with behind the scenes.
We see massive buildings and roads going up literally every single day. But to understand their true environmental footprint, we've got to zoom in and ask about the waste we don't see. The construction materials industry, the folks producing the cement, the aggregates, the glass, and the roofing materials we rely on, operates on a truly colossal global scale. And an operation of that magnitude, it doesn't just produce building blocks, it produces literal mountains of waste. Now, some of this waste is harmless, sure, but a whole lot of it is absolutely not. So what exactly happens to these invisible byproducts? And more importantly, how are companies held accountable for them?
Okay, let's unpack this using the SASB standards. These provide a really rigorous framework for tracking exactly how this industry manages its most hazardous byproducts. Now, under the stewardship of the ISSB, that's the International Sustainability Standards Board, these standards basically hand investors and companies a standardized rulebook. They cut right through the greenwashing and force a look at hard, quantifiable metrics. For the construction materials sector, having this framework is absolutely crucial because it shines a massive spotlight on areas companies might otherwise prefer to keep in the dark.
Section 1. Meet cement kiln dust, the invisible byproduct. To really grasp the sheer scale of this issue, we have to look at the absolute villain of the story, the most significant waste category in the entire industry. I'm talking about cement kiln dust, or CKD. Now, here's where it gets incredibly ironic. This fine-grained, highly alkaline dust is actually captured by air pollution control devices. So when companies scrub the exhaust gases of their massive cement kilns to prevent air pollution, they end up creating a huge toxic solid waste challenge right there on the ground. It's like you fix one problem up in the air, and you instantly create this massive, heavy physical problem down below.
Section 2. The risks of industrial waste. A tale of two realities. Now, looking at these waste risks reveals a really fascinating duality. It brilliantly illustrates this deep industry tension. On one side, the industry actually boasts pretty high recycling rates for general construction materials. But simultaneously, on the exact opposite side, it faces severe and mounting regulatory risks from managing hazardous waste like CKD. The standard explicitly points out this balancing act. You've got high general recycling, but the waste from pollution control devices remains a massive regulatory vulnerability. They're constantly juggling being an efficient recycler with being a safe custodian of toxic byproducts. And when we say hazardous, we're not just using a buzzword. The standard relies on strict definitions. In plain English, if waste is categorized by ignitability, corrosivity, reactivity, or toxicity, we are dealing with materials that can literally catch fire, eat right through their containers, spontaneously explode, or completely poison local ecosystems. If a company doesn't have an applicable local legal definition for this, they're guided to use the UN Basel Convention. So we are talking about severe physical and chemical threats here. Managing this isn't just tossing it in a landfill. It requires highly specialized, incredibly expensive containment and treatment.
Section 3. Tracking the mess. SASB metric EMCM 150A.1.
So, with all those massive risks established, how do investors actually track this hidden mess? Well, they use a specific SASB metric that forces companies to report their waste footprint in 3 very clear sequential steps. Step 1, what is the total amount of waste generated, measured in metric tons? Step 2, exactly what percentage of that mountain of waste is officially considered hazardous? And Step 3, what percentage of that waste is actually being recycled or remanufactured? This 3-step process is brilliant because it removes all the ambiguity and forces a company to reveal the true nature and fate of its waste.
You can see how this specific metric ensures companies reveal not just the sheer volume of their mess, but exactly how dangerous it is and how much they're successfully repurposing. It sits right alongside other heavy-hitting metrics like greenhouse gas emissions and water management. By formalizing this into a hard, quantitative metric, investors can literally put 2 competing cement manufacturers side by side and see instantly which one is drowning in hazardous waste and which one has actually engineered a solution.
Section 4, reduce, reuse, recycle. What actually counts? You know, in corporate sustainability, a vague definition can hide thousands of tons of toxic material. That's exactly why this framework focuses strictly on tangible physical byproducts. We're talking slags, sludges, and dusts, especially our main culprit, cement kiln dust, along with things like used oil. Notice what's missing. Gaseous waste. That's explicitly excluded because gaseous exhaust is tracked under completely different metrics. The standard defines waste as anything the entity has no further use for and just discards or releases. This keeps the metric laser-focused on the physical, solid, and liquid messes left behind.
Now, here is a really surprising fact, kind of a gotcha moment in the standards. Even if a company burns its waste to recover energy, the standard explicitly states that this does not count as recycled material. You might logically think, hey, they're burning the waste to power the kiln, that's recycling, right? Nope. The SASB standards are incredibly strict here. Energy recovery through direct incineration is completely excluded. To actually count as recycled, that waste has to be reprocessed or treated and made into a final product or a component for a new product. Simply burning it away doesn't get you off the hook for this metric.
Section 5. The bottom line, why this matters.
Let's zoom back out for a second. Why go through all this trouble to count every single metric ton of toxic dust? Well, because if companies fail to manage this stuff, an environmental problem very quickly cascades into tangible, painful business risks. Environmental laws are constantly evolving, right? They're getting stricter and way more punitive. A company generating a massive percentage of hazardous waste and failing to recycle it is basically a ticking time bomb. They're looking at regulatory penalties, fierce community pushback, increased litigation, and just sky-high operating costs for hazardous disposal. Ultimately, treating hazardous waste not just as garbage, but as a heavily regulated liability is the absolute only way to safeguard the bottom line. As the source material points out, entities that actually reduce these hazardous waste streams and figure out how to recycle their byproducts can significantly drop their regulatory and litigation risks. The companies that innovate here, the ones structurally solving the CKD problem, are the ones that will thrive. They aren't just saving the environment, they are aggressively cutting down their legal risks and overhead costs. So after digging into all of this, how will tracking this hidden data change the way you look at a concrete building? The next time you walk past a brand new construction site, I really hope this explainer leaves you thinking about the invisible world of dust and data left behind. Every single ton of cement poured represents an unseen ledger of environmental trade-offs, complex pollution controls, and hazardous byproducts like cement kiln dust. But by utilizing strict data and tracking frameworks, we can finally begin to hold the industry accountable for the unseen foundations of our modern world. Thanks for joining me to uncover the data behind the dust.